Shall we move on to the Seaborn? Okay. So in this, you will understand why actually you need visualization. So now we'll be dealing with Seaborn, and from this you'll understand why you have to actually use visualizations. So data visualization is an important part of any data analysis. It helps us to recognize relations between variables and also to find which variables are significant or which variables can affect the predicted value. In machine learning model, while training any model, you need to first find which features are important or on which features the result is dependent. So this can be done using data analysis and data visualization. And now we will be learning how to visualize different types of data and what we can infer from the plot and when to use them. So we have a library called Seaborn, which is built on matplotlib itself, and it is very easy to use and can work easily with NumPy and Pandas data structures. So we'll be using inbuilt data set provided by Seaborn, which is tips. So Seaborn has different kinds of data sets which are inbuilt. We can make use of those data sets to see these kind of visualizations. So here we will be using the data set tips. Seaborn will have so many example data sets, I have already told you. And let's work with tips data set. So first, in order to work with Seaborn, you have to import the library. How do you import the library? Import Seaborn as SNS. Import Seaborn as SNS. Now I am loading the data set which is already there in the Seaborn library. All right. How to load it? And I'm giving my data set name as tips. The variable name as tips. Tips is equal to SNS dot load underscore data set of tips. Just execute this and now see tips, TIPS. If you see this, it has some of the features. What are these features? And this data set is about a sample data set that consists of observations on tip providers in the restaurants. Tip providers in the restaurants. So total bill is nothing but the total bill paid by the customer. Tip is nothing but the tip provided by the customer in the restaurant. Sex is whether the tip provided by the customer is female or male, whether he smokes or not, when did he come, whether it is on Sunday or anything, what is the time, whether it is during lunch or dinner or breakfast, and what is the size of the people who came to the restaurant. So the first observation you can see, two people came at dinner time and it was a Sunday and they were not smokers. Those are females who paid a bill of 16.99 and gave a tip of 1.01. So this is what the observations about. So let's see some of the visualizations on this data set. Likewise, we have scatter plot in matplotlib. You also have scatter plot in Seaborn. So how can you use that? SNS dot scatter plot of X value is total underscore bill. So X value is total underscore bill and Y value is tip. Y value is tip. And where are this total bill and tip coming from? From the data tips. So, comma, data is equal to tips. Just execute this. What happened? Sorry, data is not a string. Because we already taken that as the variable, right? Just execute this. Then you can see the scatter plot. That means the distribution of the points. So from this, can you tell what is the information that you have inferred? Can you tell what is the information that you have inferred? Guys, you didn't find any information from this? Lesser the total bill, lesser the tip. Higher the total bill, higher is the bill. Yes. So from the above scatter plot, we can see that as the total bill increases, the tip is also expected to increase. So the same thing you can also use by drawing matplot. So how can you draw with the help of matplot? First import MATLAB library, matplot library. Scatter of tips of total underscore bill, comma, tips of tip, comma, marker is equal to star. So can you see the same graph is being plotted? Yes. So you can use matplot or matplot or Seaborn for the visualization. So this is the Seaborn scatter plot and this is the matplot scatter plot. Now let's see the line plot of a Seaborn, and I would like to plot the graph between size and the tip. So I can write SNS dot line plot of X is equal to size, comma, Y is equal to tip, comma, data is equal to tips. Just execute this. So now can you please tell me the relation between size and the tip? Both are plotting things only. Seaborn is mainly built on matplot. So you can use both the things for visualizations. There is no difference with that. All right. For this you are getting that error, Krishnavamsi. Now, so I asked you what is the relation between size and tip. No one told me. From this also, you can infer that as size increases, tip increases. And there is a linear relation, somewhat linear, not exact linear, but somewhat a linear relation between size and a tip. All right. So likewise, we have distribution plot in the in the Seaborn. So how do you plot the distribution plot? SNS dot dist plot of tips of tips. So here I want to see what is the distribution of tips over all the data. Tips of tip, not tips, because I have only tip column, right? Now if you see, it's showing the distribution of the data. So this dist plot or distribution plot plots the occurrences or density of a specified feature in the data set. Density of the specified feature. So what is the density of the specified feature? That is tip. So from the above image, we can see that most of the tips given by the customer lie between 2 and 4. So if you see, most of the tips are lying between 2 as well as 4. So if you see the total bill also, total underscore bill. If you execute this, so most of the highest bill is lying between something around 15 to 17. 15 to 17. So like that, you can use this distribution plot. Likewise, distribution plot, we have another plot called bar plot. So let's see how do we plot bar plot. SNS dot, and this bar plot can be plotted between an integer as well as a string data or a textual data. So what are all the string, integer, yeah, integer and a string data. So here, what are all the string or the textual data that you have in this tips data set? What is the textual data and the integer data or the numerical data in the data set? Time, day, time, day, sex, or textual data. Total bill, tip, and size are the numerical data. So now let's plot the graph between size and the tip. So SNS dot box plot of x is equal to size, comma, y is equal to tip, comma, sorry, let's say day, not size, let's say day. Day is equal to x is equal to day, y is equal to tip. You can see anything, but for now, let's see day and tip. Data is equal to tips. Just execute this. Bar. I'll show you what box plot is. Bar plot. So if you see this, what can you infer from this plot, guys? What is the thing that you can see? On Sunday, the tip is more. You can say that weekends. On weekends, the tip given by the people are more. You can also see 6. Who is giving more tip? Male are giving more tip than the female. Alright. So this is the bar plot where you can see the relation between the tip given by the. So these are all the categorical plots you can say. Bar plot is a categorical plot, and we also have cat plot. I'll discuss about cat plot within few minutes. But before that, we have another important plot which is called as box plot. So see SNS dot box plot of x is equal to size, x is equal to size, comma, tip is equal to y, or y is equal to tip, comma, data is equal to tips. So if you see this, you got something like this. Yes or no? So what are all these things? We will understand now. So while talking about data.describe yesterday, we got some sort of statistical information, right? We got some sort of statistical information. Yes or no? That is like mean, median, 25%, 50%, 75%, something like that. Yes or no? Yes? Did you remember, guys? So yesterday I said I'll explain this 25%, 50% and 75% during visualizations, I told you, right? Yes, okay. So here, this is the one size. So people who came to restaurant is only 1. People who came to restaurant is only 2. People who came to restaurant is 3. People who came to restaurant is 4. People who came restaurant is 5. People who came restaurant is 6. So one person, so there will be so many individual persons who will be coming to the restaurant, and they are giving the tip between $1 and $2. Bit $1 and $2. The size of 2 people are giving the data, I mean the tip between 1 and 6.7 or so. 1 between 1 and 6.7. So 3 people, the average, the 3 people who came to the restaurant gave the tip between something like 1.5 to 6.5. So can you see this, guys? Can you see like this? Yes? Did you understand what is this 1, 2, 3, 4, 5, 6 and all? Did you understand, guys? You calculate the whole thing from this line to this unnecessary part, from this line to this unnecessary point, from this line to unnecessary, from this line to unnecessary. Yes? Wait, I'll tell you. Unnecessary, some sort of things, right? So from here to here, 4 people gave the bill from $3 to something like $9. And here the size of 3 gave, okay, 6.5. Here we have no. So let's take that as 10 or so, or 11. Something else like that. Yes? So let's see, these are the things. Now what are these lines in between? What are these lines in betweens? Basically, whenever you're plotting a bar graph or something else, whenever you're plotting the box plot, your data will be divided into quartiles. Let's suppose I have this data 1 comma 10 comma 23 comma 23 comma, or else 1 comma 3 comma 7 comma 5 comma 8 comma 9 comma 11 comma 12 comma 90 comma 3 comma 4. Okay, so let's suppose this is the data that I have. Okay, so first what happens is the data is sorted. Sorted, it means it's nothing but it is first sorted in the range of ascending to is descending to ascending. So 1 comma 3 comma 4 comma 5 comma 7 comma 8 comma 9 comma 11 comma 12 comma 90. Did I miss something? I have two threes, right? 3 comma 3 comma 4 comma 5 comma 7 comma 8 comma 9 comma 11 comma 12 comma 90. Now dividing it into quartiles, dividing into quartiles, dividing in. Okay, so if the data is like this, first it gets sorted. After it gets sorted, can you tell what is the median of this data? Can you tell what is the median of this data? It is 7. Yes or no? Or else let's take a paint and I'll explain you. Okay. So this is the sorted list. Yes or no? Now, this is the median. MEDIAN. Yes? So now, can you divide this part? Can you divide this part into two halves? Can you divide this part into two halves? Guys, I'm asking, can you divide this into two parts, and where can I divide it? You cannot divide it into two parts? You can't? At the 3, you can divide it, right? Can't you divide? Here, you can divide it 11. Third quartile. So now, if you see this one and your graph, okay, this you can consider as the minimum value. This line you can consider as the minimum value. So first, suppose this is my graph, all right? Yeah. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and somewhere around 90. All right? Yes? Now, so what is the minimum number in this? What is the minimum number in this data? This is 1. So the minimum is 1. So here also, whatever the line that is there over here is nothing but the minimum value of the tip given by two individuals coming to a restaurant. Two individuals coming to a restaurant. Now, coming to the what is the maximum level? What is the maximum value over here? What is the maximum value, guys? 90. Okay. But if you see this, what the variance between these points and this is somewhat very high. Variance is nothing but the variation. Yes. So the difference between this and this is somewhat less. The difference between this and the maximum point is somewhat less. But the difference between this and 90 is very high. The variation is very high. So that's the reason it is considered as an outlier. So a dot is printed. A dot is given over here. So now here also from 1 to something like 10 or something else, this 11 is considered as an outlier. So a dot is drawn. So remaining, if you omit this 90 and see what is the maximum value. If you omit this 90, can you please tell me what is the maximum value? It is 12. So this is 12. If you see, this one is the maximum value. Now, what is the median? What is the median? 7. 7 is the median. What is the first quartile? First quartile is nothing but 25% of the data. Median is nothing but 50% of the data. Third quartile is nothing but 75% of the data. So now, what is the first quartile? I have divided this, right? What is the first quartile? It is 3. What is the third quartile? It is? Median is 7. This is 11. Now just draw a box. So, 25% of the data is lying between 2 and 5. 50% of the data is lying over here. 75% of data is lying between 2 and 12. Did you understand now how this bar graph or a box plot is created? So for 3 size, minimum is 2, maximum is 4. The high variation value is considered as outlier. All these values are considered as outliers. Now can you see, if you see this data set tips dot describe, you can see for size, the minimum is 1, the maximum is 6, 25% is at 2, 50% is at 2, 75% is at 3. All right. So it is considering about all the values. So what is the size we have? Data set of size dot unique. Tips of size of unique. So we have 2, 3, 4, 1, 6, 5. Yes or no? Now sort it. 1, comma, 2, comma, 3, comma, 4, comma, 5, comma, 6. So we have so many, we will have so many values like this. So you can have 1, 2, 3, 4, 5, 6. We have how many rows we have in tips? 244. Out of 244, you can have so many ones, you can have so many twos, you can have so many threes, something else like that, right? Right? So all those get sorted out. Now what is the median of this? It is around 3.5 or so. Yes, but it is given as 2. The reason is you might have 1 comma 1 comma 1 comma 1 or 1 comma 1, 1 comma 1 comma 2 comma 3 comma something up to 244 values. So whenever you see the median of that, that is nothing but your 2.0. If you see the first quartile, it is nothing but 3. If you see the third quartile, if you see the first quartile, it is again 2. If you see the third quartile, it is 3. So for this size, the box plot can be like this. So what is the first quartile? What is the minimum? It is 1, right? Minimum is 1. Maximum is 6. 50% is 2. Median is also 2. 35% is 3. So the box plot for just the size can be like this. Just the size, right? But box plot for tip as well as size. Box plot for tip as well as size is shown over here. Have you seen? That is for just size. What I've showed, this is for size and tip. So each size there will be number of tips. So for each tip, this is being calculated. Now did you understand what is this box plot is? Now did you understand, guys? These are nothing but called as quartiles. Quartiles. So how much ever big the data is, that will be divided into 3 quartiles. The first is nothing but 25%, the second is nothing but the median, and the third is nothing but the third quartile. Understood? So this is what the box plot is giving. So you can say that, okay, the median value, the median, the median value, the middle value is 3, the maximum is 4, the minimum is 5. So 25% of people gave 50% of the people gave 3 rupees, 75% of the people gave 4 rupees. Something else you can get like this. So this is what box plot is. So box plot is very important, guys. And then we have something called cat plot. So what is that cat plot? SNS dot cat plot of X is equal to smoker, comma, Y is equal to tip, comma, data is equal to tips. If you see this, the same thing you can find. So even though male, you can say this is smoker and this is tip, right? Smokers gave highest tip and non-smokers gave, the tip given by smokers is higher than the tip given by the non-smokers. So this is also a scatter plot which will give the distribution of the categorical and numerical data, right? And you can also check the distribution of the plots between two categorical data and one numerical data. So how can you do that? So X is day, Y is tip, and I want to compare it with 6. Hue is nothing but the comparison argument, and I give it as 6. If you just execute this, you can say that on Thursday, oranges are male and oranges are female and blue color are male. So from this also you can infer some sort of the information. So on Thursday, more male came, female people are less, and male people gave the highest tip. On Friday, female are higher and male people are like less, but tip was given, that highest tip was given by the male person. Here also, on Saturday to the restaurant, more number of male people came and less number of female people came, but the tip given by the male is high. The same thing here also. On Sundays also, the visitors to the restaurant is male and the highest tip given by the people is male itself. So this is the cat plot. Understood, guys? We also have another plot called count plot. SNS dot count plot of X is equal to smoker. So it will say how many smokers came to the restaurant, comma, data is equal to tips. If you see, 90 people who are smokers and 150 people who are non-smokers. 150 people who are non-smokers. This is a categorical data, right? So if you just put a bar plot here, it will ask for the numerical data as well. Bar plot is plotted for integers, right? So if you have any count, then you can plot it. But this is smoker. Smoker is not an integer and you cannot plot a bar plot. You can only have the number of counts. So count plot will count the number of categories that are there. All right, Vaishnavi? Now the important plot. The important plot for Seaborn is pair plot. So the one of the simplest way to visualize the relationship between all the features, the pair plot method gives more information. So how do you see that? SNS dot pair plot of tips. If you see this, you can consider that. So we have plotted different plots, right? X and Y. Here, if you see in the matplot, we have used subplots and plotted the graphs, right? Did you remember? Just now. So all the plots are plotted in the same figure. All right. So by using pair plot, you can plot the graphs between each and every entity and you can see the relation. So here you can see on the x-axis, this plot is between size and the total bill. This plot is between tip and the total bill. This plot is between total bill and the size. So this one total bill versus tip. This one tip versus tip. This one size versus tip. This total bill versus size. This plot is between tip versus size. This plot is between size versus size. So you can see the relationships. So the relation between tip and total bill is linear relation. The relation between total bill and tip is linear. But the relation between total bill and size is not linear. I mean, you can say that it is getting increased, but the distribution of points are somewhat different. So this is what about pair plot is. And you can also compare it with some other categorical. So how can you do that? You just give hue is equal to time. Hue is equal to time. Just execute this. What is the error that I got? KDA bandwidth is 0. Oops. Cannot estimate the density. Oops. Why is it throwing error for day? Let's see. Smoker. You're able to see the plot for smoker but not Q&A. So let's install another package. Let's see. Account up front. Install stats models. already satisfied, but why is it not? Guys, you don't do it. I'm just trying it. So that is a package error. So we have to create a good, I mean, you have to see which package you have to do. So maybe 1.1, 0.1, 0.0 is the good package. So let it be. So if you see this, cool warm, palette is nothing but the theme of your graph. So you can put cool warm or rainbow, cool warm or rainbow, or bright or something else. So if you see here, this light sky blue is smokers and green is no. So if you see this, total bill and total bill, person who paid 10 rupees was a male and non-smoker, and he gave a tip of 1 rupee, $1. Or a person who gave tip of $10 is a male and the size of the people is 45, something like that. Okay, so from here you can plot all the graphs in a single frame with the help of pair plot. So pair plot is mostly used for seeing the relations. All right. So if you are getting any errors, guys, so please upgrade your Seaborn to 0.10.0. So I've shown you how to upgrade it before, right? For Krishnavamsi, in the same way you can upgrade it. Pip install Seaborn is equal to 0.10.0. All right, guys, this is what about pair plot is. The other most important thing is heat map. What is this heat map? Heat maps are very useful and intuitive plots where we have a matrix of data. So let's see how do we create a heat map. Okay. So what I'm doing is I'm just taking a figure, plot dot subplot of fig size is equal to 5 comma 4, 5 comma 4, and to this I am adding a heat map, sns dot heat map of tips dot correlation. So I'll see what is this correlation is. Unnecessarily I've uninstalled that. That's okay. So if you see this, a matrix is created. Okay, this correlation will give some of the color combination, but what I want to annotate that color combination, I mean the numbers in it. So what does that actually mean? I would like to do that. So for that what I do is comma N naught is equal to true. Just execute this. So you got some numbers like this, right? 0 0.6, 0 0.41, 0 0.49, 0 0.6, something else. So let's see what are all this. Actually, this correlation is from Pandas library. If you see that the correlation between total bill and total bill is 100%. The correlation with total bill and tip is 67%. The correlation between total bill and size is nothing but 0.59. So here you have to consider four parameters. One is greater than 0.5, one is less than 0.5, and other is greater than minus 0.5, and other is less than minus 0.5. If suppose the value is greater than 0.5, that means this variable is highly that means as one entity increases, other entity increases. So you can say this is a positive correlation. Positive correlation if the value is greater than 0.5. So that means here the correlation between tip and total bill is 0.67. So that means it is greater than 0.5. So it is highly correlated. Now if suppose if the value is less than 0.5, this is not very significant for predicting. I mean, this is not very significant for or not very significant or not correlated. So if the value is not less than 0.5, the correlation between the entity and the combined entity is not very good. This is negatively less correlated, and this is negatively highly correlated. So that means this is inversely proportional, this is directly proportional. So whenever you are working on regression problems or so, you can check the correlation between all the input variables versus output variable. If suppose let's suppose size is the output variable. Let's suppose size is the output variable and total bill tip are the input variables. Okay. So total bill versus size, the correlation is 5.9. So that means that is highly correlated. Tip and size are not very highly correlated or not negatively highly correlated. So from total bill and tip, you can consider that total bill is having more excuse me. So total bill is having more dependency on size. So from this heat map, you can check whether you can put these values or remove these values. If suppose your values are less than 0.5 like 0.2 or 0.1 or 0.3 or greater than 0.5, then you can directly remove those columns and train the algorithm. So with the help of these heat maps, you can understand which are all the features which are very necessary and which are not necessary. So this is all about Seaborn visualizations is. All right, guys. So if you have any doubts, you can ask me. Do you have any doubts, guys? Do you have any doubts? Did you understand this correlation concept? Correlation concept and that quartiles concept? Guys, I'm asking you only. Can you please give me the response? If you don't understand, please let me know. I'll again explain you. First, suppose I'm taking an Excel sheet. Okay. So let's suppose I want to find the predict the house of a price. Okay. I have input variables like this: area, square feet, type of a house, type of a house, banks, type of a house, and let's suppose it has temperature, temperature of the area, humidity of the area, and I have price here. All right. Now tell me, what is the correlation between area and price? Is it necessary to have area to predict the price of a house? Is area necessary to predict the price of a house? Yes. Is square feet is necessary to predict the price of a house? Type, type, temperature? No. Humidity? No needed. So whenever you see this tips.core, this value will have greater than 0.5. That correlation value. The correlation value between area and price will be greater than 0.5. The correlation between square feet and price will be greater than 0.5. If suppose it is negatively correlated, but suppose type and price are negatively correlated, then the value will be less than minus 0.5. This will have either greater than minus 0.5 or less than positive 0.5. The same thing over here. All right. So based on these values, you can say which is the feature which is having more effect on the price. So that is what this correlation is. So in this, you are not able to see because you have only 3 numerical values, right? Did you understand, guys? Did you understand this? What is this correlation now, Jiva? Yeah. Anything else?